Welcome to Astronomy Daily, your daily guide to the universe and everything happening in it. I'm Anna.
And I'm Avery. It is Wednesday, April the 22nd, 2026, and it is a big day for fans of humanity's most well-traveled spacecraft.
It really is. Today we have 6 stories, ranging from the bittersweet to the thrilling, and 2 of them touch on Mars in very different ways.
We've got a legendary probe fighting for survival 15 billion miles away, organic molecules hinting at life on the red planet, a black hole that makes our sun look like a birthday candle, SpaceX hitting a stunning reusability milestone, a sobering reality check for the Artemis program, and tonight's sky.
That is a full show. Let's get into it, shall we?
I'm ready to go.
Our lead story today is about a spacecraft that launched before most of our listeners were born and is still, against all odds, calling home.
Voyager 1, the most distant human-made object ever built. Right now, it's more than 15 billion miles from Earth, so far away that a radio signal takes 23 hours just to reach it.
And on April the 17th, NASA's Jet Propulsion Laboratory sent it a very difficult command. Engineers turned off the low-energy charged particles experiment, the LECP, one of Voyager 1's last remaining science instruments.
The LECP had been running almost continuously since Voyager 1 launched in 1977, nearly 49 years. It measured ions, electrons, and cosmic rays from interstellar space, data that literally no other instrument anywhere in the universe could provide.
So why turn it off? The short answer is power. Voyager 1 runs on a radioisotope thermoelectric generator. It converts heat from decaying plutonium into electricity, and that power supply loses about 4 watts every year.
After 5 decades, that decline has become critical. In late February, during a routine roll maneuver, Voyager 1's power levels dropped unexpectedly, and the probe came dangerously close to triggering an automatic undervoltage fault protection. Basically, the spacecraft would have shut itself down in self-preservation mode.
That would have triggered a multi-day recovery process from 15 billion miles away. The team needed to act first, so they made the call: switch off the LECP.
It's worth noting, this wasn't a panic decision. Years ago, the Voyager science and engineering teams sat down together and agreed on an ordered shutdown sequence. Which instruments would go offline first to keep the most scientifically valuable systems running as long as possible. The LECP was next on the list.
Of 10 original instrument sets on Voyager 1, 7 are now shut down. Only 2 remain active: the magnetometer, which measures interstellar magnetic fields, and the plasma wave subsystem, which listens for density changes in the plasma surrounding the spacecraft.
There is a sliver of hope on the LECP, though. Engineers left a tiny motor, just half a watt, running inside the instrument. It keeps the sensor able to rotate. The idea is that if engineers can find more power somehow, there's a chance the LECP could switch back on.
And NASA is working on exactly that. The team is developing what they're calling the Big Bang, an ambitious plan to swap out a group of older, power-hungry components all at once with lower power alternatives. The goal is to buy the spacecraft significantly more time.
They're planning to test the Big Bang on Voyager 2 first. It's slightly closer to Earth and has a little more power to spare, so it's the safer test subject. Those tests are scheduled for May and June. If they go well, the same fix will be attempted on Voyager 1 no sooner than July.
And if it works, there's a chance the LECP comes back online. The ultimate goal is to keep at least one science instrument operating on both Voyagers well into the 2030s.
So, is this the end? Not yet, but it's the beginning of the final chapter. Every day, Voyager 1 drifts a little further into the unknown, still sending back data, still functioning in a region of space no other human-made object has ever reached.
For context, Voyager 1 was designed to last 5 years. It has now been flying for nearly 10 times that. Whatever the engineers at JPL have to do to keep it going, I think most of us are quietly cheering them on.
Absolutely. 49 years, still out there, still talking to us.
Our second story today takes us to Mars and to a discovery that's making astrobiologists sit up very straight indeed.
NASA's Curiosity rover has just published the results of a chemistry experiment that had never been attempted on another planet before. And what it found is genuinely remarkable.
Published yesterday in the journal Nature Communications, the study describes how Curiosity used a chemical called tetramethylammonium hydroxide, TMAH, to break apart larger organic molecules in Martian rock samples. The idea was to reduce complex compounds into something the rover's instruments could actually read.
And the results? More than 20 distinct organic molecules, including several that had never been confirmed on Mars before. Among them, a nitrogen-bearing molecule whose structure resembles a precursors of DNA, the first time anything like that has been found on the Martian surface.
Curiosity also detected benzothiophene, a large double-ringed sulfurous compound that's commonly found in meteorites and asteroids, which raises an interesting question about where all this organic chemistry actually came from.
That's the crucial caveat, and scientists are being very careful to flag it. This experiment cannot tell us whether these molecules came from ancient Martian life, from geological processes on the planet, or from meteorites that rained down billions of years ago. The chemistry looks similar in all three cases.
Mead researcher Amy Williams put it this way: the same stuff that rained down on Mars from meteorites is what rained down on Earth, and it probably provided the building blocks for life as we know it on our planet. So even the most conservative interpretation is pretty profound.
What the experiment does confirm strongly is that complex organic molecules can be preserved in the Martian subsurface for over 3.5 billion years. That's huge. It means Mars can hold on to the kinds of chemical signatures that could tell us whether life ever lived there.
The samples were taken from the Glen Torridon region of Gale Crater, an area rich in clay minerals that scientists believe was once a lake bed. Those clays are particularly good at locking in and preserving organic compounds over geological timescales.
And the timing matters for future missions too. The Rosalind Franklin rover, the European Space Agency's Mars mission, carries a longer drill than Curiosity and will bring TMAH experiments of its own. Dragonfly, heading to Saturn's moon Titan, will carry similar chemistry. Curiosity has effectively proven the technique works on another world.
The Mars Sample Return mission, which would have brought Martian rocks back to Earth for definitive analysis, has effectively been canceled under the current U.S. administration. So the path to a definitive answer has narrowed, but the evidence is still accumulating.
Building blocks of life preserved for 3.5 billion years on Mars. That's not a smoking gun, but it's a very interesting set of footprints.
Now, from the edge of our solar system and the surface of Mars, we're going somewhere truly wild. Story 3 is about black holes and a measurement that scientists have been trying to pin down for decades.
Researchers led by Curtin University in Australia have published a new study in Nature Astronomy that directly measures for the first time the instantaneous power of jets erupting from a black hole.
The black hole in question is Cygnus X-1, one of the most famous systems in the sky. It was the first black hole ever confirmed, and it sits about 6,100 light years away. It has a mass around 21 times that of our Sun, and it orbits a massive blue supergiant companion star.
The jets coming off this black hole are extraordinary. The study found they carry energy equivalent to the output of 10,000 suns, and they travel at roughly half the speed of light, about 150,000 kilometers per second.
What's especially elegant about how this measurement was made is that the team used the companion star as a kind of natural instrument. As the black hole orbits its companion, the star's powerful stellar winds push the jets sideways, bending them, like a strong gust bending water from a fountain.
By measuring how strong those stellar winds were and observing precisely how much the jets were deflected, the researchers could calculate the jet's real-time power for the first time ever. Previous estimates had only been able to average jet energy over thousands or even millions of years.
They called these the dancing jets because the direction of the jets shifts as the black hole and star move around each other in their orbit. It's a beautiful image, actually. This immense destructive force dancing.
The finding also confirms something theorists have long assumed but never proven directly, that roughly 10% of the energy released as matter falls into the black hole is carried away by the jets. That number has been baked into cosmological models for years. Now it has actual observational backing.
And the implications go well beyond just Cygnus X-1. The physics around black holes scales consistently. So a measurement from a black hole 21 times the mass of our sun can anchor our understanding of black holes millions or even billions times more massive, the one sitting at the hearts of entire galaxies.
There's also a lovely Australian connection here. The Square Kilometre Array Observatory, currently under construction in Western Australia and South Africa, is expected to detect black hole jets from millions of distant galaxies. This new measurement gives scientists the calibration point they'll need to interpret all of that future data.
10,000 suns, dancing, half the speed of light. I love this job.
Same, every day.
Just before we head into our next story about another SpaceX record, I'd like to take a moment to remind you to check out this episode's sponsor, NordVPN. If you really care about your online privacy, you really should be using a trusted VPN service. Not all VPNs are equal, but we use Nord and can certainly vouch for them. If you'd like to check them out and save a heap of money in the process, just click on the link in the show notes for our special deal. NordVPN. Visit them today and secure your online life. Okay, Avery, back to you.
Story 4 is a milestone that would have seemed like science fiction just a decade ago. On Sunday, the 19th of April, SpaceX completed its 600th successful landing of an orbital-class rocket booster.
600. The landing happened during a Starlink mission from Vandenberg Space Force Base in California, the Starlink 1722 mission, carrying 25 broadband satellites into low Earth orbit.
The booster involved, B-1097, was making its 8th flight. It came back down and touched down perfectly on the drone ship, Of Course I Still Love You, in the Pacific Ocean. The 600th recovery, as routine as it gets.
What makes that number extraordinary is the pace at which it's arrived. SpaceX hit 500 landings in September 2025. That means the jump from 500 to 600 took just 7 months. Booster recovery has gone from an audacious experiment to a production line operation.
And SpaceX Vice President of Launch, Kiko Donchev, confirmed the breakdown on social media. 496 of those 600 landings have been on autonomous drone ships at sea and 104 on solid ground at landing zones.
And remember where this all started. The very first successful Falcon 9 land landing was in December 2015. The first drone ship landing followed in April 2016. The success rate since then has climbed to essentially 100%.
Reusing the most expensive part of the rocket, the first stage, has transformed the economics of getting to orbit. Each refurbished booster saves tens of millions of dollars and allows SpaceX to maintain a launch cadence that no one else can match.
And all of that expertise feeds directly into Starship, the massive vehicle designed to eventually carry humans to the Moon and Mars. The 600 landings aren't just a number, they're a foundation.
600. Congrats to the SpaceX team.
Story 5 brings us back to the Artemis program, and we're still glowing from the success of Artemis II, which returned safely to Earth just 12 days ago. But today's story is a sobering companion to that triumph.
Because even as the program celebrates getting humans further from Earth than anyone has been since Apollo, a significant problem is quietly growing on the ground. And it centers on something that might sound mundane, the spacesuits.
NASA's Office of Inspector General released a report on Monday, the 20th of April, and it makes for uncomfortable reading. The central finding: the next generation spacesuits that astronauts are supposed to wear on the lunar surface during Artemis III, the actual moon landing, may not be ready until 2031 or later.
Which would be 3 years after the 2028 target date that NASA leadership is still publicly defending.
The suits are being developed under a program called Exploration Extravehicular Activity Services, EXVA. NASA originally selected 2 companies, Axiom Space, building the lunar surface suit, and Collins Aerospace, building a microgravity suit for the ISS.
Collins is effectively out. According to the OIG report, Collins began missing milestones within about a year of its contract award. It completed its preliminary design review a full year late before NASA and Collins agreed to descope and wind down the contract. Collins had actually received an excellent rating during the proposal process, despite concerns NASA program managers already had about the company's existing spacesuit work. The OIG was not flattering about that source selection.
So Axiom Space is now the sole contractor building the suit intended for the lunar surface. And the OIG's math on that situation is stark.
Looking at comparable NASA human spaceflight programs, commercial cargo, commercial crew, Orion, the Space Launch System, the average time from contract award to first test flight has been 8.7 years. Axiom's EXVA contract was awarded in 2022.
Apply that historical average and first flight lands in 2031. The OIG was careful to say it isn't formally predicting that outcome, but it also said the projection was more realistic than the original schedule. In auditor language, that's pretty pointed.
NASA Administrator Jared Isaacman pushed back on April 20th, posting on social media that NASA is inserting its own subject matter experts directly into Axiom's development work, and is confident the suits will be ready for a 2028 lunar landing. Axiom has said it plans to test the suit in 2026, either on the ISS or during an Artemis-related mission.
The OIG's response, essentially, is that a demonstration suit and a crew-rated lunar surface suit are very different things, and the gap between them is measured in years, not months.
And the problem doesn't stop at the moon. The ISS version of Axiom's suit also slips past 2030. NASA faces a scenario where the space station literally runs out of operational spacesuits before a replacement is certified. The current EMU suits are decades old, and there's a hard deadline. The ISS is being decommissioned at the end of this decade.
The OIG report also notes that the spacesuit delay sits within a broader context of Artemis 3 schedule pressure. A separate report from March found SpaceX's lunar Starship lander at least 2 years behind schedule, and Blue Origin's Blue Moon lander at least 8 months late.
Every component of Artemis 3, rocket, capsule, lander, spacesuit, is on its own delayed schedule. The critical path isn't any single element, it's whichever one finishes last.
That's the uncomfortable reality. Artemis 2 was a genuine triumph, and we should celebrate it. But the road to boots on the moon is still longer and bumpier than the official timeline suggests.
We'll keep watching it, and we'll keep reporting it.
And we'll finish tonight with something much more immediate and much more beautiful. Story 6 is your skywatching alert for this evening.
Tonight, Wednesday, April 22nd, look up after sunset and you'll be treated to a lovely conjunction. The half moon is sitting just 3 degrees away from Jupiter, with the pair framed beneath the twin stars Castor and Pollux in the constellation Gemini.
3 degrees is close enough that you can cover both with the width of 3 fingers held at arm's length. With the naked eye, it's a beautiful pairing, 2 of the brightest objects in the sky, side by side.
And if you have binoculars, even better. You should be able to pick out Jupiter's 4 Galilean moons as tiny dots flanking the planet: Io, Europa, Ganymede, and Callisto, in a little line.
For our listeners in the southern hemisphere, you'll find the pair in the northwestern sky after dark, tracing their arc toward the horizon through the evening. The further south you are, the shorter the viewing window, so don't wait too long.
A half moon is actually a pretty good time for this kind of observation. It's bright enough to make a dramatic visual companion, but not so overwhelmingly bright that it washes out everything nearby.
So step outside tonight, look northwest after sunset, and say hello to Jupiter. It's been the standout planet of this season, and it's still putting on a show.
That's all for today's edition of Astronomy Daily, Season 5, Episode 90. Thank you so much for listening.
If you're enjoying the show, please subscribe wherever you get your podcasts and leave us a rating or review. It genuinely helps new listeners find us.
You can find us at astronomydaily.io and on social media at AstroDailyPod on all the major platforms.
For Avery, I'm Anna. We'll see you tomorrow.
Clear skies, everyone.